Hello everyone and welcome to this part of the presentation. So far we've established what AI and machine learning are, and we've seen the workflow of how machine learning systems work in practice. Now comes an essential question: what are the different ways you can actually train a machine learning system? So it turns out that machine learning algorithms can be trained in many different ways, and each method has its own advantages and disadvantages. Each approach is suited to different types of problems and different kinds of data situations. Based on these different training methods and learning approaches, machine learning is essentially categorized into four main types. Understanding these four types is crucial because they form the foundation for almost every machine learning applications that you'll see in risk management and even outside of risk management. So let's start with supervised machine learning, which is probably the most common type used in a business application. So in supervised machine learning, machines are trained on labeled data sets. That's where the word supervised comes from. The labeled data set is one we've already identified the correct answer. We've marked the examples in our training data with their correct classification or outcome. Let me give you an example from credit risk. Imagine you have historical data on 100,000 loan applications, and for each application you have information about the applicant, like their income, credit history, employment, debt level, and so on. But you also have something crucial, that you know the outcome, because these loans already happened, and you already know which borrowers defaulted and which ones didn't. So the outcome then is labeled. So the labeled data set here, we have essentially input variables, which are the predictors. So in that case, we said income, credit score, employment history, etc. And then we have the output, which is the label, did the loan default, yes or no. The key phrase in the definition is that some input and output parameters are already mapped. So this person with these characteristics ended up defaulting, or this person with these characteristics paid as expected. Because the inputs and outputs are already mapped, the machine is trained with the input and corresponding output. It learns to recognize when I see these combinations of input features or characteristics, the outcome tends to be that, either default or payment. The machine then learns a function, which is a mathematical relationship that maps inputs to outputs. Of course, this is not going to be a simple linear function. As you'll see, we have different options to select from. Once trained, this function can predict the outcome for new unlabeled data. A new loan applicant comes in with unknown credit risk. You run the information through the trained function, and it predicts this person has a 5% probability of default, for example. Now, supervised machine learning isn't just one approach. It's further broken down into two broad categories. And this distinction is important because they solve different types of problems. Classification is used when the output is a category. For example, default or no default. Is the email spam or not spam? Is the transaction fraudulent or legitimate, and so on. So the output is a discrete category, a yes or no in this case, fraud or no fraud, default, no default, and so on. You're classifying the data into categories. Classification algorithms include naive Bayes, which is a probabilistic classifier based on Bayes' theorem, nearest neighbor, which classifies data based on similarity to nearby training examples, discriminant analysis,